So in this video we're going to develop the standard and general equations for planes in space. So if we have a plane in three-dimensional space, we need two pieces of information regarding that plane in order to make its equation. So the first thing that we need to know is a point on the plane, and then we need to know a vector that is normal to the plane, and where normal means perpendicular to the plane that we're interested in. And the idea is this. The idea is that if we have a plane and we know a point in the plane. So here's a point right here, the point x1, y1, z1. So we know a point in the plane, and then we know a perpendicular vector to the plane, a vector that's normal to the plane. So let's call him n for normal vector. If we have any other point in the plane, so let's pick an arbitrary point in the plane right here. Here's the point x, y, z. I can make a vector from the point I know, x sub 1, y sub 1, z sub 1, to the arbitrary point in the plane x, y, z. Let's call that vector u. And the idea is if the normal vector ABC is perpendicular to the plane, then the vector that's perpendicular to the plane must be perpendicular to any vector that's in the plane. And what we want to do is take advantage of the fact that in a previous video we discovered that the dot product of perpendicular vectors is equal to 0. So in this case that means that the normal vector n, if we take the dot product of the vector perpendicular to the plane and we dot it with a vector u that's in the plane, so we'll say the vector from x sub 1, y sub 1, z sub 1 to x, y, z is given by the vector u. If we take the dot product of those two vectors, that dot product has to equal 0. Well, how do you find the vector u? Well, u is just going to be the vector. We know how to find a vector if we know the initial point and the terminal point. We take the difference between the x, y, and z components. So we would do x minus x sub 1 to get the x component of that vector. We would do y minus y sub 1 to get the y component of that vector, and z minus z sub 1 to get the z component of that vector. And then again, a, b, c is just any vector that you can find that's perpendicular to the plane. So this means then that u and n must be perpendicular to each other, so their dot product, if we take the dot product of x minus x1, y minus y1, z minus z1, the dot product of those two vectors has to equal 0. So if we take the normal vector a, b, c and dot it with a vector in the plane, that dot product has to be 0. And a dot product is easy to calculate. It's just the sum of the products of corresponding components. So it would be the x component a times the x component x minus x sub 1 plus the y component b of the normal vector times the y component of the vector in the plane, y minus y sub 1, plus the z component of the normal vector times the y component of the vector in the plane. And so we wind up with an equation. This is the general equation of a plane right here. So this is the general equation. And then if we wanted to, we could use distribution to distribute the a, the b, the c into the parentheses. So we could push this a little bit if we wanted to. I'll get that out of my way. So we could do a times x minus a times x sub 1 plus b times y minus b times y sub 1 plus c times z minus c times z sub 1. And this would need to equal 0. And then we could just group things. Do ax plus by plus cz plus the other stuff. And the other stuff's just going to be a number because x sub 1, y sub 1, z sub 1 are a point. Those correspond to a point we know. And abc corresponds to a normal vector. So we get, if we group these, minus a x sub 1 minus b y sub 1 minus c z sub 1, this is just going to be a number and we can give it a name. We can call it d. And if we do that, then we get ax plus by plus cz plus d equals 0, and this is the sorry, I got them backwards. This is the standard up here. This guy is the standard equation of a plane. Standard equation. And down here, this guy is the general equation of a plane. And D is just going to be this summation right here, minus ax sub 1 minus by sub 1 minus cz sub 1. So next slide just summarizes the results. We get the standard equation given by this, and really what we want to do is recognize this is just a dot product of perpendicular vectors equaling 0. And then distribution allows us to regroup the terms that have x sub 1, y sub 1, z sub 1, and we name it D to get the general form of the equation of a plane. So these are the two most common equations of a plane that you'll see.